Welcome, my name is Kevin Otieno and this is Form 4 Mathematics. The topic today is loci. So under loci, which is the plural of locus, we will look at types of loci, and in a series of videos to come, we'll look at different types. But to begin with today, we have perpendicular bisector locus and angle bisector locus. Now, in order to go through this, we will have this question to guide us. So the diagram below, so it's alongside, represents a failed PQR. Then part A, draw the locus of points equidistant from sides PQ and PR. Part B, draw the locus of points equidistant from P and R. And then part C, a coin is lost within a region which is nearest to point P than R and closer to side PR than to side PQ. Shade the region where the coin can be located. So we will begin with part A, and the task here is identifying the type of locus that we have. So the locus of points equidistant from sides PQ and PR. Equidistant simply means equal distant from PQ and PR. So here we have two line segments. We have line PQ and line PR. So if we have PQ and PR, what can they form? So that is the question we need to ask ourselves. Of course, PQ and PR meet at point P, so we have a common point P. So the other line PR begins here. So probably you can draw it downward so that we have R at that particular point. As you can see from our diagram, we have PR and PQ. So PQ and PR form an angle. And if at all we are to bisect something, then it is the angle that we are going to bisect here. Because if we have PQ and PR forming that angle, bisecting PQ alone would only mean you are bisecting line PQ, and it has nothing to do with PR. So in order to involve both PR and PQ, then definitely it has to be the angle to bisect. So this is an angle bisector locus. So we're going to bisect the angle at P, and once we've bisected, automatically we'll get to realize that any point along this line, which is the locus of the points we are looking for. So let's call this point X. So the distance from point X to PQ, that is the perpendicular distance from point X to PQ, should be the same as the distance from the same point X to PR. So that is how the term equidistant arrives at this problem. So given that we've known that it's angle bisector locus, now we are going to carry out this on the diagram. Next, we bring a pair of compasses and place the end of the pair of compasses at point P, which you want to bisect, and then we'll have to make an arc on both line PR and PQ. So put an arc there, and next come to this PQ and do the same like that. And then at the points that we've marked, we will have to draw an arc as shown for that, and repeat the same procedure with the other point. So with this other point also, put an arc. So putting the pair of compasses aside, next we bring a ruler. Put the ruler so that it passes through point P and the point of intersections of the two arcs, and then you draw a line, pass through exactly those points you've marked. Sorry, that did not come out well as required, so we have that. And then put your ruler aside so that we have the angle bisector, which is now the locus of points equidistant from PQ and PR. Next, in part B, we are told to draw the locus of points equidistant from P and R. So again, for P and R, we have a line segment. So we have line PR. So we have P, R. So for line PR, if at all you are to bisect something, then it is the perpendicular bisector of PR. So that the distance from this perpendicular bisector, which is the locus, should be the same from P to the line and also from R to that line. So here we've identified that we are going to bisect line PR, that is the side of the triangle PR. So again, we bring a pair of compasses. And now, in order to bisect PR, bring this end of the pair of compasses to point P. And then next, we will have to draw an arc. So let's have an arc beginning from there, so that we draw it right down like that, and come to this other side, repeat the same procedure. So you come here and draw it nicely like that, and then move the pair of compasses to point R and repeat the same procedure. So unfortunately it doesn't get where we want it, but it will still work. So let's just draw it and then we'll get back to that other point. Let's have that right there. And then on the other side, fortunately they are meeting, so have it right there. And remember, we have to maintain the radius of the pair of compasses. Let's not interfere with that. So next, let me get to this other point P. And once that is done, let me see if we have it passing exactly through that point. I think I've just missed it slightly. It should get it right there. Oh no, oh no, 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 oh no. So this is getting a little bit difficult to use. Okay, so from there we can extend the line so that we have it right there. They are meeting at that point. And then we put the pair of compasses aside. So this is the point where we can make use of rubber when we realize that we draw something which tends to be too long. It's not what we expected. So neatness at times is necessary. So for this particular point, we've drawn the two arcs. Now we are going to join the 2 points, this point and that point right there. So the next thing, we bring a ruler to help us in joining. So next, once the ruler is in its position, then we can join the 2 points. A straight line as shown. And once that is done, get the ruler away. In fact, let me do away with it. So we have the locus of points equidistant from P and R. So that perpendicular bisector of line PR is the locus. From there, next we are looking at question 3, rather part C of the question. So a coin is lost within a region which is nearest to point P than to R. So when you're talking about nearest to P than to R, P and R gives us a line segment, line PR. So here we are focusing on the perpendicular bisector because we're talking about PR here. The information gave us the perpendicular bisector of PR. So when you talk about nearest to P than to R, the side of this locus which is nearer to P than R is this other side, the upper part, which is towards point P. So that is nearest to P than R. So, and closer to side PR than to side PQ. When you talk about PR and PQ, again, that is now about the angle bisector locus. So the angle bisector locus was here, this line here, that is the locus of points equidistant from PQ and PR. So the side closer to PR than to PQ is the side of this locus towards PR. So if we are to shade, we are going to shade following the instructions that we've been given, so the rules. So the side we are shading is closer to P than R. The side closer to P than R on this locus inside the triangle is that side. It's closer to P than R. And the side closer to PR than PQ, if you have the locus of points equidistant from PQ and PR, the side closer to PR is this side. So we shade it. So we can shade it completely so that we have something that looks like this. So once that is done, now that is the region where the coin can be located. So we are told that a coin was lost somewhere within the triangle, but the conditions are where the coin can be found is closer to P than R and closer to PR than PQ. So we are asked to shade that particular region within the triangle. So that is it. The region in green is the required region. Otherwise, that's it about perpendicular bisector locus and angle bisector locus. I hope this was helpful. See you next time.